Today's video is going to be covering solving systems of cost equations. As I go through this, I'm just going to highlight and annotate the key information that I see. Over the weekend, families rushed to the theaters to see the summer blockbuster Sharks. All tickets were sold at the box office. Child tickets cost $6 each, and adult tickets cost $10 each. The total revenue collected was $1,500, and 200 total tickets were sold. How many child tickets were sold is the first question that we have to answer.
So we're going to identify our two unknowns, and the annotations actually do that for us. So we've got child tickets at $6. We know how much they cost, but we don't know how many were sold. We'll call that C, the number of child tickets. We don't know the number of child tickets. And then we know the cost for adult tickets, but we don't know how many were sold. So we'll call the number of adult tickets A. Then total revenues we know, and total tickets we know. So we can begin to create our two equations based off of the totals.
So I'm going to go ahead and make the total tickets equation. Our total tickets sold was 200, and we know that our child tickets plus our adult tickets is going to equal that, so we can go ahead and say A plus C equals 200. And then we can go ahead and make a cost equation, or equation based on the total revenue, that's a better word. We know that the total revenue generated was $1,500, and we know that the adult tickets cost $10 each, and we know that the child tickets cost $6 each. If we add these together, we're going to get the total revenue generated.
So in order to use elimination, that's our next step. To use elimination, we need to scale these. So I'm going to multiply this top equation by -6, and I end up getting -6 times A is -6A. -6 times C is -6C. -6 times 200 is -1200. We can add these two equations, and 10 minus 6 is 4A. 6 minus 6 is 0, so we call that elimination, that's 0. And 1,500 minus 1,200 is 300. 4A equals 300. We use inverse operations to divide by 4, and A equals 75. But the question's asking how many child tickets. We have 75 adult tickets. So to get child tickets, we'll plug it back into the tickets equation. We know that the number of adult tickets is 75 in our tickets equation, plus C, which we don't know yet, equals 200. Using inverse operations to subtract 75, C is equal to 125. I can go ahead and box that, and I can write it in or type it into the blank.
Good, now we can answer the second question. Assume that the total number of tickets would not change. How much would the theater have made or profited if each ticket cost $10? Well, they sold 200 total, right? So if they sold 200 total and each ticket cost $10, all we need to do is times the total number of tickets sold by $10, and that will give us the amount of money that they profited. So 200 times 10, since we're multiplying by 10, we can just add a 0, is 2,000.
On to the next one. Over the weekend, families rushed to the theaters to see the summer blockbuster Sharks 2. All tickets were sold at the box office. Child tickets, so again we're underlining tickets, cost $3 each. Well, that's a revenue. And adult tickets, that's a tickets, cost $5 each. That's a revenue. So total revenue was $3,000, and total tickets was $800. Now I'm ready to identify my variables. Well, they're the same. We don't know the number of child tickets, and we don't know the number of adult tickets. So now that I've identified my variables, I'm ready to create the equations.
Good, so let's go ahead and start by creating a total tickets equation. In our total tickets equation, we know that the total number sold was 800, and we know that the child tickets plus the adult tickets should equal that. And then we can go ahead and make a total revenue equation. Well, we know that the total revenue made was $3,000, and we know that the cost per child ticket was $3, so $3 times the number of child tickets sold, added to the cost of an adult ticket was $5 times the number of adult tickets sold will give us this 3,000. So we can go ahead now and create our opposites using scalar multiplication. So you can see that the numbers in front of C and A are both 1, so I'm going to go ahead and multiply by an opposite. The easiest number for me to multiply by is a -3, so I'm going to multiply by -3. And I can't fit it over here, so I'm just going to write it right here. I'm going to multiply by this -3, and I'm scalar multiplying this to all of the terms. So I get -3 times C is -3C, -3 times A is -3A, and -3 times 800 is -2400. I now have my opposites, so when we add down, we know that C will be eliminated. What we get here is 2A equals 600. We can now go ahead and solve for A by dividing both sides by 2, and we get that the total number of adult tickets was 300. But we don't want the total number of adult tickets, we want the total number of child tickets, so we're going to take the number of adult tickets, 300. We know that the total sold was 800. So we're going to go ahead and solve for C to find the child tickets. So minus 300 on both sides. And we know that the total number of child tickets was 500. Whoop, that's 5,000. Didn't mean to add that extra 0. It's 500. Go ahead and type that in our blank.
Now to answer the second part, assume the tickets sold would not change. How much would the theater have profited if each ticket cost $5? Well, we have 800 tickets sold times the $5 price tag. Bring the zeros down. 8 times 5 is 40, so we end up with $4,000 that would have been made.
This will be our last one for today. So over the weekend, families rushed to the theaters to see Die Hard. What a great film. All tickets were sold at the box office. Child tickets cost $7 each. Adult tickets cost $10 each. And the total revenue collected was $306. The total number of tickets sold was 36. How many child tickets were sold?
Well, we're not sure how many child tickets were sold, so we'll label that. Number of tickets is going to be C. Number of child tickets is going to be C. And number of adult tickets is going to be A. So I'll go ahead and write my equations. The first I will write is my tickets equations, all my underlines. So my child tickets plus my adult tickets is equal to 36 total tickets. Then I can write my revenue equation. $7 for each child ticket plus $10 for each adult ticket equals $306 of revenues. Again, I need scalar multiplication so that I can eliminate these. And I'm just going to go ahead and use -10. So I'll scale by -10. -10 times C is -10C. -10 times A is -10A. -10 times 36 is -360. When I sum these two equations, 7 minus 10 is -3C. 10 minus 10A is 0. That's why it's elimination. And 306 minus 360 is -54. So I have just enough space to divide by -3. And C equals +18. Well, because it's solved for C first, I don't have to find the adult one, so I can go ahead and plug in 18 here.
Just for kicks, I'm going to find the adult one. So I'm going to plug in C, which is 18. A is for the adult tickets is 36. So we know that 18 plus what number gives us 36? Well, we know that the total number of adult tickets was also 18. That's just for funsies. Alright, the second question, assume that the total number of tickets did not change. So we know that the total number of tickets was 36. How much would the theater have profited if each ticket cost $10? So we're going to go ahead and take 36 and we're going to multiply it by $10. 36 times 10 is 360. So we know that the theater would have profited $360 if they charged everybody a flat rate of 10. Good luck on your homework. Make sure that as you go through these, the numbers that you get for A and C are positive numbers, because if you're getting a negative number, it doesn't make any sense if the theater's selling a negative amount of tickets. Think about that as you do the homework.